So hello everyone, today we'll be understanding about Bitmask DP as well as how to optimize Bitmask DP, because sometimes you know um, like bits are limited, right? I guess you know what's the idea of Bitmask DP. It's basically this way. When you want to maintain unique elements, when you want to maintain unique elements in state, that means probably you want to maintain a set kind of data structure in a state, right? You want to maintain a set, let's say dp of some I comma some set. This is what you want to maintain. This is what you want to maintain. You cannot maintain a set inside dp as a state, right? Like it cannot be a set. Maybe you can maintain some other small, mostly integers, but it's not that great to maintain a set, isn't it? The insertions would become complex, and also it would take unnecessary memory, etc. So what do we do is, I guess if you know some basic stuff like DFS and BFS, in that we used to maintain some visited array. What does a visited array used to do? A visited array used to have initially all zeros, 0 0 0 0 0, which used to denote unvisited, and some would be marked as ones. Let's say this is marked as 1, this is marked as 1, this is marked as 1. What does that mean? That means these three nodes are visited. That means visited array is some sort of a set of visited nodes, right? It's acting like a set, isn't it? It's acting like a set. So what if I use some sort of visited array kind of thing? That's where the intuition of Bitmask DP comes from. And since maintaining array is also definitely hard inside the state, we instead use, see, we need to deal with zeros and ones. What's the first intuition? What if I use a number that has, now here there's 1 2 3 4 5 6 zeros. What if I take a number that has 6 zeros? What if something gets visited, I do an OR operation with 1. I do an OR operation with 1 and make this one this way, right? That means I can make, if I am visiting this, I can make this as visited. If I am visiting this, I can make this as visited, isn't it? So this is the intuition of Bitmask DP. Since you cannot maintain a set inside your state, you try to maintain a mask. So this is the basic idea. Okay. And sometimes, let's say you want to maintain some 100, 200, 300 unique elements. Okay, it won't go that far. Let's say some even 64-bit is there, but actually 128-bit is also there, but let's say some 64 plus. Let's say you want to maintain this. Okay, let's say you want to maintain this above 64 something, 65 or 66 or something. What happens? The bits are not sufficient sometimes. Okay, you cannot have huge bit values, right? You cannot store many elements. That's the catch, isn't it? When you're using a bit mask, what's the catch? The range should be very small, then only you can use a bit mask. Otherwise that many amount of bits an integer cannot store. Okay, so to overcome this, we sometimes, not always, sometimes we can do some sort of optimization, and mostly the optimizations we can do are either you can invert state variables. I would explain what does this mean clearly. You can invert state variables, or else maybe sometimes due to space optimization itself, the space becomes so small that suddenly the range gets compressed and you can actually fit it. Next, another, this is very rare. The problem should heavily support you. Until and unless problem heavily supports you and expect you to expects this to happen, it won't happen. So forget about this. It's very rare. Okay, state inversion, the inverting state variables is also very rare, but it's pretty doable. If you analyze properly, it's doable. In some 50%, 60% of the problems, it is doable. Another go-to solution is coordinate compression. You might have heard about this in segment trees. It's not very same here, except the fact that names are same. Coordinate compression is something you can use. Okay, wait a minute. Mouse is, yeah. Coordinate compression is something you can use. So what is this coordinate compression? Let me tell you. Let us say you have, usually when you do bit masking, you might have contagious values, very contagious values, right? So let's say this is the thing. In this case, you don't need coordinate compression. In this case, you don't need any kind of coordinate compression. Why? Because 0 would denote the bit position 0, 1 would denote the bit position 1, 2 would denote the bit position 2, 3 would denote the bit position 3, 4, 5, etc. Okay. So if you want to mark 0 as visited, you would mark this as visited. If you want to mark 3 as visited, you would mark 0, 1, 2, 3, this as visited. If you want to mark 5 as visited, you would mark this as visited. Fine, it's very easy. But let's say the values are 0, 65, 42, 53. You cannot actually do anything. So in this case, what you do is you take these values, give them numbers, like you give this 0, you give this 1, you give this 2, you give this 3, this way. And if you want to mark 53 as visited, you mark 0, 1, 2, 3. If you want to mark 53 as visited, you mark this as visited. If you want to mark, let's say 65 as visited, you mark this as visited. Okay, fine. You give the numbers. Okay. So this is basically coordinate compression in simple terms. We'll see how are we gonna do it and all. So let's get started with the problem. Okay. And this problem is interesting because many beginners would mess up because of YouTube tutorials. So you need to understand recursion very clearly before getting started with these kind of things, because we will be writing recursive code. Okay, let me tell you something that I don't usually go for iterative DP. I don't usually go for iterative DP until and unless I'm very sure. Like if it's a very clean DP thing, until and unless it's a very clean DP thing, like I know every single transition correctly that it would 100% work, then iterative DP is fine. To think and engineer the problem, usually recursive DP is a kind of better way. So we'll write some recursive logic, that's for sure. And now let's see the problem. I'll also tell you my way of writing recursive DP, which is kind of works out for every other problem. So let us see the problem. You are given a 2D matrix grid consisting of positive integers. You have to select one or more cells from the matrix such that the following conditions are satisfied. Okay, you need to select one or more elements from the matrix such that the following conditions are satisfied. So remember one thing, if it gives you some optimization related thing or counting related thing, these are only the two things possible via DP: optimization, counting. And if you implement either of one of these logics, you can generate. This is a rarer question. Okay, mostly DP is all about optimization or counting. Forget about constraints. First step would be forget about constraints. There are no constraints. First thing, forget about constraints. There's no constraint. It's an optimization problem. You need to do some sort of maximization. Now let's read the constraints. We need to maximize. Remember this, we need to maximize. No two selected cells are in the same row of the matrix. The values in the set of selected cells are unique. Fine. The values in the set of selected cells are unique. Fine. Done. Now, I asked you to forget about whatever is like the constraint. If you want to simply write the recursive logic, let's say we are going row wise. Fine, we are going row wise. So every row, let's call it level or row, your wish. Let's call it row or let's call it level. Fine. Let's take int answer, which would denote the maximum sum. So, tell me something. You are iterating over columns. Okay, you are iterating over columns. Let's say I is the column number. You are iterating over the columns. So DP is nothing but it's like a DFS. You need to visit all the possibilities. There's a state. You need to visit all the possible states. So if you pick column number 0, if you pick column number 1, if you pick column number 2, these are different states possible. So you're iterating over all the neighbors. Think it that way. You're basically doing a DFS on a DAG. DAG is directed acyclic graph. Why directed acyclic graph? Because DP compresses a recursion tree into a DAG. Fine. You are iterating over these columns, which are your potential neighbors. Okay, these are your potential neighbors. So if you are iterating over them, what's the value that would get added to your sum? The value that would get added to your sum would be array of level column. This would get added to your sum, and answer equal to, you need to maximize it. What are the possibilities? You can either select one or more cells. Okay, no two selected cells are in the same row of the matrix. Fine. You can select one cell or you can select more cells. It's not necessary that from every row you will be selecting one cell confirm. No, it's not necessary. You might be like, but the constraints say everything is possible. If I want to maximize something and everything is possible, everything is positive, why should I avoid picking some elements? You might be questioning me. But let us say there's 5 here. You cannot pick unique elements. You can pick only unique elements. You cannot pick non-unique elements. And in other row also you have 5. In this case, I am leaving this row, right? Isn't it? The second row I am leaving. So these kind of cases may occur. So this is maximum of recursion of don't pick anything, just move to the next level. Or okay, this is one thing. Don't pick anything, move to the next level. This is one of the possibilities. Or pick something. What are you picking? You are picking A of level, and in this level you are picking this column. Fine. This is what you are adding to your sum. or you can simply write it as val. Fine. Val plus the remaining maximum sum you obtain from other levels. Okay, so what are you doing? You're taking a state, you're moving to the next state, you're sending the sum of this thing and moving to the next state, so that this gives you some other maximum sum, and your element plus that whole maximum sum would give you the answer, and at the end you need to return the answer. Fine. It's a simple DFS logic. Now let's talk about the base cases. If level is equal to n, in that case you should be returning 0, because after that nothing is pickable. Fine. Now we only have level here, right? We only have level here. We need to declare other stuff globally. Fine. Vector int a, int n, int m, and do we need something else? Not really. So let's do grid equal to, sorry, a equal to grid, n equal to grid dot size, m equal to grid of 0 dot size, okay, m equal to grid of 0 dot size, and yeah, you should maximize answer also. Okay, you should maximize the answer, so answer should be there. And that's it, right? But did you notice something? This particular thing, recursion of level plus 1, is independent of this for loop. So why should it stay in the for loop? Let's keep it here. Why should it stay in the for loop? Let's keep it here. Fine. So observe these kind of things properly, otherwise it would be unnecessary time taking step for the compiler, and you need to return recursion of, you should start from 0, isn't it? But we haven't handled any kind of constraints yet. We are just maximizing. We are trying to pick at least at most one element from each row. We are trying to pick at most one element from each row, and we are not checking it's unique or not yet. Okay, so let's make an unordered set to do that. Okay, so if the set already has the value, do not take it again. If set already has the value, do not take it again, continue from there. If it doesn't have that value, insert that value into the set, because you're picking it. But by the end of this recursion thing, you may not be picking it, so erase it from the set and move on. How does this work? Simply, let's say there's 1 2 3 in the first row and 2 1 6 in the second row, and you have picked 1. F will contain 1, F has 1, and you move to the next level, When you move to the next level, let's say you have 1 again here, so since it's there here, 1 is already there enough, you cannot pick this one, also, because 1 is already there here. Okay, you can pick 6, so the thing you will get is 7. Now let's move to the next one and start recursion from here, Now you can pick 1, because by the time you move here, you would erase this, so that's how it would work. Let's check if it's working or not as expected. Okay, so the recursion logic absolutely works. Now A total beginner would do this. Okay, I have written the recursion logic. This is 10. Let me take 11, obviously, because 10 should also get included. Now I would do memoization, right? Now I would do memoization. This is what a beginner will do. Okay, before computing, add a check whether this thing is already previously computed or not. If it's previously computed, it won't be -1, so return it. And before this, do a memset dp -1. This is what a beginner will do, and this would fail. I said it would fail too early. Okay, fine, it failed. Now you might be asking me, why did it fail? So let's take a simpler matrix. Let's take 1 5 1 5 4 5 1 5 4 5. What are we trying to do? First take 1. Okay, now 1 is into f. Now let's move to the next row. Next row you can take 4. You can take 4 because it's not 1, it's unique. You can take it, and with this, after this you'll get level equal to n, so nothing can be taken after that. You'll get a return 0. Now 1 plus 4, what is it? 1 plus 4, 5. Fine. So now you are storing. This was level 0, right? For this you have executed dp and you have got the answer 5. So you are saying that dp of 0 equal to 5. You are writing dp of 0 equal to 5. Now done. 1 is done. Coming to 5. You are pushing 5 here. Wait. Why am I even computing? I did an intelligent move by placing a dp of level not equal to -1, then return level. Now dp of level is not equal to -1, so return dp of level. That means return 5. I did a really wise move, right, by returning 5 here. But actually, when you take 5 and when you take 4, the answer you get is 9. Without computing it, you are taking the previous computation, which is not the actual answer, and returning it. Why is this happening? This is happening because a bad state design. Actually, can't even call it bad. It's incorrect state design. What does incorrect state design mean? Is your state only depending on dp of level? Like, is your state only depending on the row number? No, your state is already depending on the value you take, and the value you take is depending on this unordered map f, isn't it? You are storing this value, and which is not equal to -1. You are unable to verify it, and you are returning it, which is a blunder, I would say. So beginners, before directly returning these kind of things, which you call so-called memoization, check if state is depending on other stuff also, like unordered set, like this unordered set. Now the question is, can you maintain an unordered set in the state? Can you maintain this unordered set inside the state? No, right? How can you maintain an unordered set? It would be really, like, first thing, it would be slow. That's one thing. Unordered set would be slow. Second thing, what data structure would you use? Maybe you might be like, I can use a map of pair of I can use a map of pair of int unordered set of int. If you are planning to do this, please don't do this, because first thing, unordered set cannot act as a key, so you have to use set, and set can do act as a key, so it's a little sensible thing to do as a beginner, but trust me, this would be immensely slow. If you're trying to do this, this is not the way. Okay, so we have a better technique, which is Bitmask DP. It is no rocket science. Instead of using this data structure, what are you trying to do is, you can store an integer. You can store an integer this way. You can store an integer this way into this, right? Maybe you can't, because it's 100. So it's a 10 cross 10 grid. So there would be 100 unique values even after coordinate compression. Coordinate compression, as I told you, you eliminate the sparse stuff. But what if it is 0 to 99 contagious? In that case, you have to take 100 bits. 100 bits, which integer would give you? Which data type would give you? So that's not how it works, isn't it? Instead of maintaining this set, I'm telling you to maintain what do I say? I'm telling you to maintain an integer which looks somewhat like this. There would be some n here. Fine. But is that optimal? Is that optimal? Yeah? No, right? Because 100 you cannot have here. You cannot have a 100 here. Fine? Cannot have a 100 here. So what do I do? Now in this case, I am trying to pick. From each row, I am trying to pick column wise. What if I do reverse? Instead of this, what if I would do columns and row wise. The number of rows is 10 and 10 can fit in. This is possible, right? This is absolutely possible. One left shift 10 is possible. Number of rows is 10. Basically, instead of calling this columns, I would call it values. So let's see, how would you implement this kind of thing? So instead of taking DP of level, because it's wrong and you cannot take an unordered set here, you are taking a mask. Fine. And return DP of level comma mask. Here also you should pass the mask. The mask won't change because no element is added. You're skipping it, right? You're moving to the next state directly. So no element would be added. Here also no element would be added. And here, to mask, you should be doing, wait, we haven't inverted the states yet, right? Let's first invert the states. Let's remove this recurrence logic from here. So you're iterating over all the 100. Before it was like you were doing recursion on some 10 rows, and then you used to store used values. You had used values were to 100 and this 100 was a problem. What if I swap them? This is the basic idea of state inversion. This is the basic idea of state inversion. What if I swap them? What if I take used values or simply values here? What if I take values here and what if I take rows here? Okay, we need to just invert this logic. Now don't ask me for a template. Is there a pattern for this? Is there some separate what do you say, lines of code you need to write? Like memorization, many people don't even know how it works and they just keep writing before return. Some person might have told you before return. I've seen people doing this literally. They do this. They find return, replace it with return dp of ij something. I've seen people doing this like literally. Okay, so this is a wrong thing. Understand stuff. This is the basic idea. I've told you the idea. Don't ask me for all these templates and stuff. Because they don't exist. At the end, you have the idea. That's it. Many people say there's LRDP. Is there a template? Is there a way to do? Is there LRDP? Is there some interval DP? I don't even know 2D DP, 3D DP. Okay, so that's not how it works. I've already told you the idea. Based on this idea, you would be operating. Okay, based on this idea, you would be operating. Is that clear? Now, how to implement the swap? First thing, just believe you can do it. This mask is now for rows. Okay, make sure mask is now for rows. Okay, don't mess up computing mask. Mask is now for rows. Fine. So if value is greater than 100, value can never exceed 100. In that case, you would return 0. And dp of val mask, if it's not equal to -1, I'm directly writing steps because however I need to write them. Okay. Once again, int answer equal to, directly skip it because in for loop if you write it, it's unnecessary time and space getting wasted. Val plus 1 mask. Now instead of iterating upon the columns, of a row, you need to iterate on the row. Let's take a position of val. What does position of val do? Position of val would store all the positions in which row it appeared, and if what does this mean? If in your mask, there's a 1 and you're doing this particular thing, 1 left shift by the row, and if it is both ones, what does it mean? It was previously visited. I've already told you, right? The mask basically acts as a visited array. Just like in graphs you use a visited array, mask is also a similar thing. It marks things as visited because to act as a set, that's the best thing you can do, right? Mark stuff as visited. So if mask and 1 left shift row, if this is giving you 2, then you have already visited it. Continue because you are allowed to take only unique elements. You cannot take the same element twice. And answer equal to max of answer. Val would be added to the answer. Sorry. Val plus 1. Mask. Okay. mark it as visited. This is marking as visited. When you do an OR operation, that bit gets set. Fine. This would work the same way. And since this is inside the parameter, you need not backtrack also. You need not unset it again. And you need to return DP of val mask. Fine. This is what you should be doing. Now we have used the thing which is position of val. Position of val. So what does this position of val mean? In simple terms, you are doing for int I equal to 0. Position of I dot clear, first thing. Let's iterate over the rows. Grid of row. I am just marking which rows have the position x. X is there in which rows basically. So if this particular row has x, I would push back this row. Fine. This is what position does. So basically you are trying to invert the states. You're basically trying to invert the states. Isn't it? You're basically trying to invert the states. Before this you need to declare a vector and position. What would be the size of this? It would be of size, or let's keep it this way. Yeah. So you're doing inversion basically, and due to this state has got 101 values and this one mask has got lesser values. So always try to allocate lesser number of, like, the lesser range to the mask. What happened? Fields must have a constant size in array structure. Actually this should be 10. We don't need that many. Did we miss a semicolon somewhere? Yes. Subscribe to premium. Forgot to have parentheses. Okay, recursion of 0 mask. Mask should be 0, value should be initially 1. Did we mess up somewhere? A equal to grid. N equal to grid dot size, n equal to grid of 0 dot size. I less than or equal to 100. Position of I dot clear. Fine. Row equal to 0, row less than and row plus plus. X in grid of row. Position of x dot pushback row. Fine. Name set DP minus 1 size of DP. Return recursion of 1 comma 0. Vector, vector, int, unordered set. F, we don't need it anymore. And actually we don't even need, or do we need? No, we don't need this one also. So int and intem dp of, so I need to comment it, better uncomment it. Recursion of val comma mask, if val greater than 100 return 0. dp of val mask not equal to -1, return dp of val mask. Fine, answer equal to recursion of val plus 1 mask, row in position of value. If that particular row is already visited, continue from there. Answer equal to max of answer. Okay, we are not adding val here. Val plus. And yeah, this got accepted. And this goes all the way till 100. You're iterating upon values. And this would go, it would fit in the range. Basically, you're doing 10 left shift, so it wouldn't exceed the range. Let's see if this works or not. And it passed. So yeah, by the way, I forgot to tell you, this was the fourth question which was hard in DP and had the least acceptance. So see, the technique didn't change much, isn't it? You can do hard questions also, but you should remember just a very few ideas like this one. Alright. Code looks pretty clear. So that's it. Thank you everyone.